everyone, to lesson number 1 of Unit 3. Today we're going to be talking about exponential functions, graphs, what they look like. Before we get into that, there's one term that we need to go over that you should have seen in Algebra 2, but just in case, it's an asymptote. Right? An asymptote is a value, here we're going to see it in the form of a line, that a function approaches but never actually intersects. So here we see our asymptote. It's in the form of a line. It's vertical. You can see that our function is going towards it, and then all of a sudden, instead of it crossing, it starts to go up, getting closer and closer, but never actually crossing. Okay, that's what an asymptote is. So let's look at our first exponential function, which is going to be growth. Here we see the exponential function is f of x equals some base to the power of x. That's what makes an exponential function, is the variables at the exponent. And here for growth we have our base value, something that's greater than 1. We need to know some critical points, and with exponential functions there's 3 critical points that we can work with. Okay, the first one that I'm going to look at is this one right here. Okay, it's where if we plug in 0, we're going to get out 1. So this point right here is one of our critical points, 0, 1. That one's nice because it never changes, right? It's always 0, 1. Something that we are going to talk about, though, is that this height right here is going to be 1 unit. Now, 1 unit from what? Here, it looks like it's the x-axis. Where it really is going to be 1 unit from is our asymptote. Our asymptote happens to be on the x-axis in this example. So I'm going to draw it in here with this purple. Okay, and we're going to label it. Now what's nice is that the asymptote will actually help us with our range. It's going to help us determine where our function is going to approach and all the values above it. Okay, or if it happens to flip, it's where the function approaches and all the values below it as well. Okay, so we have an asymptote and we have our first critical point. We have 2 more critical points. Our next critical point is if we plug in 1, what are we going to end up getting out? Well, let's think about it. If we put in 1 into this exponential function, b to the power of 1, that's just going to give us b out. So our second critical point is going to be 1, b. And our final critical point right here would be -1. If we plug in -1 into our function, that gives us 1 over b. Right? So here's our third critical point. It's going to be -1 and 1 over b. Now notice this is not necessarily halfway. Okay, it's 1 over b. The only thing that we know for sure as far as units go is right here, 0, 1. Okay, this is b, whatever our base happens to be. Okay, if that's a 2, then it would be 2 units away. If that's a 4, it'd be 4 units away, and this would also be reflected, right? 1/2, 1/3, 1/4. Okay, we also have transformations. Transformations for exponentials are pretty much the same as usual. First we have the plus or minus, which if we have a negative, it's going to flip. And just like all the other functions, it'll be over the x-axis. Then we have right here our a value, some sort of multiplier, and what usually happens is if our a value is greater than 1, we would think of it as getting taller, and if our a value is in between 0 and 1, we'd think of it as getting wider or shorter. Okay, then we have our x minus h value. This is going to be our left-right movement, and it's going to be opposite sign. Okay, so we've seen this in the past. If we have a plus, we want to go in the negative direction, which would be left. We have a minus, we want to go in the positive direction, which is right. Okay, and then we have our last plus k, which is our up and down motion. Okay, we want to follow the sign, and what's really nice about this is not only is it following the sign, but it's also going to tell us where our asymptote is. Okay, that's the location of the asymptote. So what you're going to see me doing with these is you're going to see me doing, most likely, the asymptote first. Okay, I'll figure out where that goes. I'll graph it right across. And then I'm going to start looking at some of the critical points. Most likely our first critical point, and then I'll start looking at the next two after that. Okay, so let's dive right into an example and see how these work. Okay, so they're asking us to graph and state the domain and range of this function. F of x equals 3 to the power of x plus 2. So there's a couple of things that we want to take really good note of. First, it's what our base is. Our base here is 3. Okay, so our b value is 3. We know it's greater than 1, so it's going to be growth. It's going to have this kind of look, starting low, and then it's going to go up. Okay, so first what I'm going to do is I'm going to plot down my asymptote, and it tells me where it's located. It's located at 2. Okay, before I actually plot that, I want to look real quick at my graph itself. Okay, if you notice here, I have my units 1, 2, 3, 4, and 5, but they're spaced apart so that I have 3 boxes in between. How I chose 3 is because of my base. Why I'm doing this is because I know one of these is going to be a fractional look, right? The -1 was 1 over b for our critical point, so I know I'm going to be working with fractions, which is why I gave myself an appropriately spaced graph. So that's why this looks this way. So for the next couple of problems, when you see a base, if you want to start setting up your graphs so that they match your base, it'll be a little bit easier to work with. Anyways, let's get back to the actual problem, right? So we want to put our asymptote at +2, right? Plus 2. So let's just draw that in real quick first. Okay. Next, I'm going to plot my first critical point, which is my 0, 1. Now, if I plot 0, 1 right here, that's where it would normally go. But this tells me that I'm shifting everything up 2. So from here, I've got to go up 2 full units. 1, 2. Let's do that in red instead. So I am up here. Notice also that the space between this is 1 unit. As we mentioned, it would have been before. Okay, so that first point that we got was 0, 3. The second point that I'm going to plot is going to be my 1, comma b. Right? In this example, my b is 3. So normally, I'd want to be here at 1, 3. But we've moved the function up plus 2. So I need to move from here up 2 more units. So 1, 2, I'm way up here at 1, 5. And we've got one more point. That's going to be our -1 and 1 over b. So if I'm at -1 and 1 over b, that would be 1 over 3. So I only want to go up a third. So I would be right here. But again, I have to go up plus 2. So I want to move up a full 2 units. Now, 3 boxes counts as a unit. So I'm going up 1, and I got to go up 1 more to right here. That's where my next point lands. That coordinate is -1. Let's see, that's 2 and a third. 2 1/3. Mixed fraction is okay here. And I just want to draw in my function going along, right? So I'm going to start close to my asymptote. I'm going to go and I'm going to hit my point, and then it's going to go up this way, like growth, and that's my function. Okay, so we've graphed. Now they want us to state domain and range. Okay, well, domain, we can look at visually going left and right. I can see that it's going that way towards the negatives forever. It's never going to stop. And I can also see, although it's going up, it's also still pointing somewhat in that direction. So my domain, it's going to be all real numbers, right? There's no restrictions on what we can plug in. So for domain, we'll write that right here, domain. We have all real numbers. Okay, no restrictions. As far as our range, we know that nothing's ever going to cross this asymptote, right? That's the value that it never crosses. So if I look at my range, I'm starting from here. I'm not including that value, which is 2, and I'm including everything above it. So that means all my y values have to be greater than 2. So that's our range. Range is going to be all real numbers such that y is greater than 2. That's our domain and range for that particular problem and the graph as well. Let's try another one. Got a different base, and it's got a couple more things happening, right? And again, quickly looking at my setup, my base is 2. So for my graph, I gave myself 2 spaces in between. That'll help me with any fractions that come up. Okay, so this time I'm going to plot my asymptote first. Says at -2. So down here is -2. That's where our asymptote is going to go. First critical point would be my 0, 1 point. So let's see, I'm going to do it in green this time. 0, 1 is up here. However, we need to go -1 and then down 2. So from here, I've got to go back 1 and then down 2 full units. Remember, my units are 2 squares large now. So here's where we landed. By the way, once again, notice that my distance here is still only 1 unit. Okay, that coordinate, that's -1, -1. Our second critical point, we're going to do 1, comma b. Our b value here is 2, so we would want to be here at 1, 2. But we're going to go -1 and then -2. So back 1 and then down 2. So my next critical point is right here at 0, 0. And we've got one more, -1 and 1 over b. So we want -1 and 1/2. So -1 and 1/2, I'm only going up 1 square this time, and then we're going to follow our directions, right? So from here, -1 and then down 2 full units. Be careful when you're counting out your units. Just make sure that you count properly, right? Because this was a halfway. We wanted to make sure that we counted following the full unit measures. Okay, so we landed at -2, comma -1 and 1/2. Now I have all 3 critical points. I have my asymptote. We're just going to connect here through. And there we have our graph. As far as our domain and range, domain for these are really nice and easy. It's always going to be all real numbers. There are no restrictions on exponential growth. As far as range, well, I'm looking at everything above this line, right? And that line started at -2. So our range is all real as long as y is greater than -2. see. Our next example involves a negative, which is going to flip us over the x-axis, and a multiplier, which is going to make this thing either taller or wider. Okay, so here we notice we've got -2. So everything's going to be multiplied by 2 as far as distances go. I have a base here of 2. So notice now my setup is spaces of 2. Okay, and I have -1, so we want to be going right 1 and then up 3. And right away I've already identified my asymptote. So I'm going to right now plot my asymptote at 3. The next one that I'm going to plot is going to be my 0, 1 point. So 0, 1. That's where it would normally be. But two things are happening to this. I am flipping it upside down. So normally I'd be up here at 1. I need to be reflecting over the x-axis. So now I'm down here at -1. And the space is now twice as tall. So instead of me being 1 unit away from the origin, I need to be 2 units away from the origin. So now I'm down here at -2. But that's not all that's happening. I'm also moving right 1 and then up 3. So from -2, I've got to go over right 1 full unit, 2 boxes here, and then up 3. 1, 2, 3. So that's where our point landed. This seems to make sense, right? I want my space to be twice as wide. I've pointed out with the last two graphs that the space was only 1, but we want it to be twice as large, and we have it twice as large here. So this is good to start off with. That coordinate is 1, 1. Next coordinate, we're going to do 1 and B. So normally we'd be up here at 1, 2. We're going to flip it upside down. Alright, so that means we're down here. And we're going to make it twice as far. So let's see, we've got to go twice as far. So here. Okay, we're a little bit off our graph. That's not a big deal. We're going to go +1 and then up 3. 1, 2, 3. That coordinate is 2, -1. We've got one more to work with. That's going to be 1 and 1. I'm sorry, -1 and 1 over b. So normally it'd be -1 and 1/2. We've got to flip upside down. So we're flipped, and we've got to make it twice as far. So normally we're ½ a unit, so we've got to go a full unit. We're right here. Then we're going to move it +1, 1 full unit, and then up 3. 1, 2, 3. So let's see, we were at 0 and 2. Now I can see my asymptote is up here. So that means that we're starting from here, and we're going to follow along and hit these points this way. So here we go. Here's my function. As far as domain and range goes, domain, it's always going to be all reals. Let's see, domain. And our range, slightly different. Again, we're not including 3, and we're using everything less than 3. So we want y. We can use all reals as long as y is less than 3. That's our domain and our range. So I have one for you to try. It's kind of a complex one. I've set up what your graph should look like. So if you want to repeat the same setup, okay, you can ignore that little spot down here. That'll put your graph nicely for you. Pause this video and resume it when you're ready to check your solution. Alright, let's check out how you did with this. First, we're going to want to plot our asymptote. They said -1. So here's our asymptote down here at -1. Okay. We know everything's going to flip over. So everything's going to be this way. And we know that our b value is 3. So our first coordinate would be 0, 1. We're up here at 0, 1. Where'd my green one go? Okay, so we're at 0, 1, and we need to move. That would be -2 and then down 1. So -2 and then down 1. Your first coordinate, let's see. Did I make an error somewhere? I think I did. Yeah, because we didn't flip, did we? We forgot this negative. So let's see. If we were at 0, 1, we'd want to flip over negative. Then we'd want to move back 2 and down 1. So your first coordinate should be -2, -2. I forgot about that flip. Let's not do that on the next one. Next coordinate we want would be 1 and b. So 1 and 3 is way up here off our chart. We're going to flip over the x-axis. So we're going to be at 1, -3, back on our plane. Okay, and then we're going to move 2 left, 1, 2, and then down 1. That puts us right here at -1, -4. And our final critical point would have been -1 and 1/3. We're going to flip upside down, and we're going to move over 2 and then down 1. That coordinate is -3 and -1 and 1/3. How'd you do with those coordinates? Hopefully you came up with those same 3. Okay, we're going to draw on our function from here, just connecting the dots and writing our domain and range. Domain, that's all real numbers. Range, it's going to be all real as long as y is less than -1. So graphing exponential growth, not too bad. We have a little bit more to discuss, and it's going to be something called exponential decay. We just talked about growth, where you noticed everything was getting bigger. Now we're talking about decay. Everything is going to start getting smaller. Okay. This time you notice the difference between growth and decay. Our b value has to be something between 0 and 1. So it's normally going to look like a fraction. They don't tend to use decimals too much for this. Okay. So here's our function. We've got our function f of x. And that's going to be equal to some fractional base, 1 over b to the power of x. Notice where your b value is here, right? It's on the bottom of that fraction. That's going to make a difference when we start talking about some of these critical points. Our asymptote is still going to be along the x-axis until we move it with our transformations, right? So we still have that asymptote. We have 3 critical points just as last time. First critical point is not going to change. If we plug in 0, anything to the power of 0 gives us 1 out. So we're always going to have this critical point, 0, 1. The ones that change now, if we plug in 1 to this function, it's going to give us 1 over b back. So instead of it being -1, 1 over b, it's now +1 and 1 over b. Likewise, if we plug in -1, that means that everything here is going to flip, so we have b over 1. So our -1 switched place with our +1's formula. Right, we have -1 and b. Okay, so now just be careful. Remember, it's not going to be a big B like this, so you're not going to be plugging in 1/2 here. You're going to be plugging in this is what your B term is. Okay, so these switch, and you'll notice the decay. It's going to go down. And I have this little side note right here, right? Transformations and domain and range behave the same as before. So when we look at this problem right here, okay, we can recognize that it's going to be decay, so we're going to be making sure that we follow this switch, right? We switched these two, okay? And I notice my B value here is 2, not 1/2, but 2, and then we have some transformations that happen to it as well. So let's go ahead and set up our graph the right way. Okay, have it spaced apart with 2 because that's my B value, and I know I'm going to be moving up quite a bit, which is why I gave myself some space. My first thing I'm going to do is plot my asymptote at +3. So let's put +3's asymptote in. Then I'm going to do my first critical point, which would be 0, 1. Then I'm going to follow my couple of things, right? It says go back 2 and then up 3. So I'm going to shift back 2 and then up 3 for my first transformation. That puts me right here at -2, 4. My next would be my 1 and 1 over b. So that would be 1 over 2. Right, so we're right here. We're going to move back 2 and up 3. So back 2 and then up 3. That coordinate is -1, and that would be 3.5. We've got one more to go. My -1, comma b here. My b is 2, so -1, 2. We want to go back 2 and then up 3. That final coordinate is -3 and 5. So we can see that everything is starting to go in the downward motion. That's decay. It's going down. Okay, as far as our domain and range goes, right, our domain is still going to be all real numbers. Right, we can plug anything we want in going left and right. The range is where our restriction comes in. We have all real as long as it looks like y has to be bigger than 3. Y must be greater than 3. Okay, so there's our domain and range for exponential decay. So I think there's one more problem that's a U-try problem. Yep, there's one more. U-try. Again, if you want to try setting up the graph the same way that I have it set up for you with space of 3, this should work perfectly. Pause this video and resume when you're ready to check your answer. Okay, let's check out how you did on this. So we want to recognize a couple of things, right? Our B value. Our B value here is 3. Okay, this whole thing is 1/3, so it's going to be decay, right? We know it's going to be going this way. My asymptote, the first thing I want to identify is at -1. So I'm going to put my asymptote right across at -1. That's all taken care of. First critical point would be 0, 1. This tells me move +2 and then down 1. So +2 and then down 1. My first critical point is going to be at 2, 0. Second critical point, 1 and 1 over b. So 1 over 3. I'm right here. I want to go +2, and then down 1. We're right here. That coordinate is 3 and -2/3. And we've got one last critical point. negative 1 in b, so negative 1 over 3. I'm sorry, positive 3 rather. And we want to go 2 to the right and then down 1. So our final critical point is right here at 1, 2. Connect those. Oops. Try not to make it bow like mine did. Should be smooth. Okay, then we just got to talk about domain range. Your domain, oops, it's going to be all reals. Hopefully you've gotten that by now. Range, well, we're talking about all values that are greater than 1. So all real such that y is greater than negative 1. There you have it. Graphing exponential growth and decay functions and looking at their domain range. If you have any questions, leave them in the comments, or better yet, bring them to class. I would love to answer them there. All right, I'll see you soon.